Howdy, AP PreCal. It is Miss Kosh. It's been a few days since I left off. I had this stack of paper right here sitting on the edge of my desk for me to make more videos. So I think I'd gotten to this point and then got distracted and had to grade 180 tests, something like that. So anyway, we're back, and I'm on Mr. Passwater's notes from topics 1.9 through 1.10. And then we'll go into 111. Is that what what do I have? Oh, that's part of the 111 stuff. Okay, I got to get in the right headspace. All right, here we go. Okay, write an equation of a rational function with the following limit properties. That as we approach 3 from the left, it equals 5. Okay, so that tells me that it's either, there might be a hole there at the point 3, 5, or it's actually defined. And there is a coordinate that's defined there. That's the point 3, 5. And then we need to approach 1 from the left and go to negative infinity, and 1 from the right and go to positive infinity. And I want more space to write. So let me grab some scratch paper. Okay, so looking at this one, let's first draw what we're talking about and then see if see how we go. Okay, so basically we have the point 3, 1, 2, 3, 4, 5. I don't know if it could either be a hole or it could be actually filled in and be part of the function. My guess is that that he was intending for it to be a hole, but okay, it's been 18 years since I taught calculus, but my understanding is that this would be, even if it's defined here or if it's a hole at that point, we would have the same limit notation. So if anyone knows calculus better than me, let me know. But okay, we also have this asymptote at +1, because what they're telling us here is that as I approach 1 from the left, it goes to negative infinity. So it's doing something like this. And then as I approach 1 from the right, it goes to positive infinity. And so somehow it's going to do something like that. So we have a whole lot of equations that could meet this requirement. So let's see. One, we'd have no, we'd have no reflections, because normally, like if my parent function, y equals 1 over x, we live in quadrants 1 and 3, which is what we're doing here. We're living in quadrants 1 and 3. So did they tell us anything else? No. So, I mean, it's a rational function, so it's going to have another asymptote of some sort. But to be honest with you, we could have it be any, well, not any, but there's a lot of different horizontal. One thing we can't do is we can't put the asymptote above this value, unless there's some really, I mean, we could get really complicated and make it like have weird stuff happen in the middle and then approach the asymptote later on out on the ends. But I'll have to go look at his answer key and see what he intended for this. But the way I see it is that we have an asymptote. This is going to, if we have an asymptote at x equals 1, that tells me I'm going to have x minus 1 in my denominator. If I have a hole here at 3, 5, then I need to be able to plug in, let's see. Let's assume it's a hole, just so that we can do that. So at 3, x minus 3, it's going to cancel. And then we can let's pretend, just for the sake of it, that we have this does meet the requirements, because he didn't tell us one way or the other, that y equals 1 is an asymptote. So then in that case, we'd have an x minus my favorite letter is k. Okay, and so we've got this type of equation, and I want to be able to plug in, okay, so if this is f of x, then I need f of 3 to equal, well, actually, it's not f. When these cancel out, after I remove my hole, then when I plug in 3 into that equation, I should get 5. So that will help me determine what k is. But so far, this has an asymptote at x equals 1. It has a hole at x equals 3, and we've got to figure out what to plug in here so that so that my hole has a y coordinate of 5. Okay, so let's call this part, I like to say it looks like, if you look in my notes, I'll say it looks like, and then G, what am I doing an equal sign? G of x is equal to, it looks like x minus k over x minus 1. Okay, so that's the equation where I want G of 3. So this becomes 3 minus k over 3 minus 1. I need that to equal 5 so that the limit as x approaches 3 from both the right and the left would equal 5. Okay, so what do I have? I have 3 minus k over 2, so equals 10. And so k would equal, subtract, that's 7, so k would equal negative 7. So I have the equation, my final answer, f of x would equal x plus 7 times x minus 3 over x minus 1 times x minus 3. That seems to meet all those requirements that he indicated. I'm curious now what his equation was. We could have made it top heavy. If I did, well, okay, if I had made it, if I had made it top heavy, then I would have just have to say, okay, I have an x minus 1, or not top heavy. Why am I saying top heavy? If I made this where there wasn't a hole, f of x is equal to this, and then maybe we have an x minus k here. I need to be able to plug in 3 and get 5. So then I would have 3 minus k over 2 is equal to 5. So k is also negative 7. Okay, that should have been obvious. When I removed that, that's what I was plugging it into, and I got 5. Sorry about that. That was kind of weird. Okay, let's see if the next one is a little more clear, not clear cut, but a little more has less room for options and less room for discernment, perhaps. Okay, so we are approaching negative 2 from the left and negative 2 from the right, and we're coming up with 4. We're approaching negative 1 from the left and negative 1 from the right, and we're going to positive infinity on both of those. Ew. Okay. What we see here is that if we're approaching negative 1 from both directions and going off to positive infinity, then we have something squared somewhere. And I need at negative 2 to get 4. I need the value negative 2. This is negative 1. Somehow that should be 4. I don't know that I want to spend my time doing that. Do you want me to do that? Well, we know it has to have something squared. La, 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 la. I don't know. Okay, you're going to watch me suffer. I don't know that AP is going to ask a question like this, but we'll try. Let's see. So I should have thought about this a little bit. I need f of negative 2 to equal 4. I know that I have a denominator. I know my f has to have, it has to have an x plus 1 in the denominator. If I square that, do I want to square that one? Then we could do an x minus k. Let's see how this works. I could be wrong. It's happened before, but not too often. I'm just kidding. Okay, well, this one I'm saying there's no hole. So f of negative 2 would equal negative 2 minus k over negative 2 plus 1 is negative 1 squared is 1. Okay, and this needed to equal 4. So negative 2 minus k equals 4. That's 6, so k equals negative 6. So what I'm saying here is f of x is equal to x plus 6 over x plus 1 squared. Let's see how I did. We're gonna grab a calculator and see if I'm onto something. Okay, so let's make that a fraction. We have an x plus 6 at the top. And I need more. Sorry, go down. And then an x plus 1, we said, squared. Okay, let's make my window. Let's just do the standard window for just a second. It sure seems to be, they both go off to positive infinity like we wanted them to. Let's see, G-solve, we were looking for YCal. We wanted to know what happens when x equals negative 2. It equals 4. Okay, I think I met the requirements. If we wanted to have a whole instead, then we could just throw in an x plus 2 over, well, this is all the, anyway, and then an x plus 2 on the denominator, so then that becomes a whole. But I don't think we have to. Okay, that was something else. Let us keep going. Sketch a picture of a rational function that has the following properties. Oh, that might be nicer, just sketching a picture. Okay, it has a hole at x equals 1. As it approaches 4 from the left, 2, 3, 4, f of x increases without bound. Okay, so here, so we're going to come here. As it approaches 4 from the right, it decreases. Okay, so we're doing this, and we're doing this, and they said we have a hole at 1. All right. Okay, g of x has holes at -2 and -3 as it approaches -1 from the left here. Okay, so here's -1. As it approaches -1 from the left, it decreases, so it's going down. But it had a hole at -2, so that's over here somewhere. And then it's approaching, so here's an arrow. From the right, oh, nope, it decreases. I'm sorry, that's wrong, I lied. So it decreases here, but we have a hole at 3. Maybe that's here, I don't know. Something like that. All right, well, that was enjoyable, if you're into that sort of thing. I'm sorry. Like, subscribe, comment down below. Let me know if that was helpful or painful. I apologize. Anyway, go practice.